Hi, welcome to the video series covering the features of the toolbox called HyperWorks LiftShip. In this video, I will be specifically covering meshing and elements. So here you can see our section here that we'll be looking at. And I also wanted to point to this package, which will be a part, should be downloadable and shared also with this video series. So at any of these stages, feel free to kind of drag and drop and open them up. So here I will be dragging and dropping 3B, which is the merge and project points. Basically all of our geometry has been prepared for meshing. Go and drop that on in here. And here you can see we still have our solid geometries that we'll need to apply thickness to, and also our points have been projected. We are good to go for meshing. And so in this section, this parameter and criteria files are very important for the remainders of these workflows. These are actually used not only in our batch mesher, they're used in the rebuild, they're used in this pad-eye and support structure creation. And I'll explain that when I get to this section a little more. So here we have our core tool. So we click on param, it's just going to load the defaults. So I think our documentation does a really good job of kind of explaining what each and every one of these features does. So I'm not going to kind of dive into those specific details, but with regards to the LiftShip program, we do have an out-of-the-box kind of recommended best parameter file. This is stored in the build, but it also can be pasted to your program files, HyperWorks desktop, HM, batch mesh. So it could be stored there, which is listed here. With regards to the build, and if I navigate over to documents, alright, so bear with me, just had to navigate to where my LiftShip build was located. So if we go ahead and open up the LiftShip build, and we go to the config file, you can see we have our param and criteria files will be located in here. So I'll go ahead and double click on this 40 mm, which is ideally suited for this geometry and the fact that we're using millimeters. So from a high level, it's loaded our target element size. We have a mixed element type approach, first order elements, mesh to the component. We also have some circle washer kind of auto recognition, and we have basically everything else been deactivated. Maybe we have some slots in the model. You can kind of see those. We have kind of this slot geometry here, and then we have our circles. Try to make it as lean as possible, but fundamentally what it's going to be doing is cleaning up the geometry and toggling off a lot of these topology lines that aren't necessary in order to meet our meshing criteria. So again, go ahead and load and apply the param file. Go ahead and click OK, and next we will load our mesh criteria. So go ahead and open up that, and it'll be our mesh 40 criteria. And it's going to be auto populated for the OptiStruct solver. So as long as we clean up the elements to meet these qualities, then our solver will be happy with us. So go ahead and click apply, and again, those can be should be modified to any given project. Those can be standardized based on your team's workflows. And one thing I forgot to mention is you can save those. So you may want to take a few parts in your assembly, apply the mesh, check if it's the appropriate quality, it's executing as you expect it, and then save that as your project's param and criteria file and reuse that obviously for your team. Kind of helps with standardization as well as obviously being used in the batch mesher. And that's the next step is once we kind of load our param and criteria files, we take a little time to edit those. We'll go ahead and select our solid to click hide, and we will go to our batch mesher, and you can see that param criteria file got loaded. If for some reason you forgot, you could also load it here in the options drop down. Let's go ahead and select all of our let's go reset here, and we'll just select all of our surfaces, hit Control A, and we'll say mesh. So for the sake of this video though, I will not execute this. It does take, for this size of model, for my workstation, it takes about 20-25 minutes. So it's good opportunity. Go get some coffee, go take a break, go get some lunch, open up another session of HyperWorks and start cranking away on something else. So what I'll do for this video is I'll actually go ahead and open up the batch meshed model. So let me go ahead and navigate over there, drag and drop, and there we go. I'll zoom in here. You can see I have my nice structured, nice flow mesh, I should say. And that's our batch mesher. The next step is we have this rebuild option, which I'll use on occasion when we want to do the final cleanup. But the next one we want to do is this map thickness. So as I had mentioned in my previous videos, in our assemblies, we have a dedicated assembly to those solids that were, or I should say parts that didn't have any thickness assigned to them. So I'm going to go ahead and isolate those. And if you recall, during the meshing, those surfaces were also included in the meshing. So just go ahead and isolate those components via the assembly browser, and we'll go to map thickness, and let's see here, we'll do properties on components. Again, these are kind of the core features of the tool, and we'll switch over to source our solids. Go ahead and select those elements, and then we'll select those solids and say apply thickness. So just give it a moment or two here. All right, so good. Looks like it's done now. Just took about a minute. And then what we can do is zoom in here and preview the thickness assignment. So again, we didn't capture the bulbs for this iteration of the design. It really depends on the goals that you have, for the analysis. So here we just want to look at the global response of the structure as we lift it. Most of the stresses will predominantly be concentrated around the points of lifting. So we'll cover that in the next steps. So we have our thickness done. So what we'll go ahead and do now, we can handle these solids in a couple different ways. So if we go over to the components and go ahead and create, we'll call this my original solids or something along those lines. It's not mandatory that they are in the original component. So I'll just grab those. We'll switch this to solids. Go ahead and select those. Click O on the keyboard or right click and organize. So I like just hit O real quick. And this is the current component. It's solid and bold. And so we'll just go and click play. Move that on over there. And then I personally will want to remove those from the active sessions. So we'll go ahead and just scroll on down here and turn these suckers off. Okay. And here we have our meshed and with thickness assigned. Go ahead and exit out the entity state, and I think we can exit out the components and assemblies. And we will go ahead and unlock our view now that we have kind of everything organized. And I'll just click A on the keyboard and reorient the model. So next is going to be our normals. And this is important for the lift manager stage. So it's going to be important if you know where you're going to have cable contacting to ensure that the normals are pointing in the outward direction. So here, this blue indicators means it's kind of pointing inward to the structure, and then if I hit reverse, now it's going to be pointing kind of outwards. Another way of visualizing that, if you're kind of newer to HyperWorks, is this vector display. We can do the size of 1, click display, Make it a little bit bigger, and click display. Okay, there we go. So now we know that it's pointing outwards. Again, as I had mentioned, this will be important for applying a cable contact. All right, so go ahead and hit return, and we'll go ahead and exit out of that. Try not to make people too sick here with me orienting my model. I always like to put in the ISO view. And that is the conclusion of this video. By now you should feel comfortable with the kind of the steps getting up to your mesh, and next we'll cover the model. I hope you found this helpful. Please leave us feedback on our Altair community forums.